Welcome back to Physics with Kate. Today we're talking about how to calculate resultant force using scale diagrams. If you like what you see here, don't forget to like, subscribe and hit the bell so you don't miss out on the next video. Before we get on to resultant force, we firstly need to understand force diagrams. So we need to know that the forces on a body are drawn as arrows showing the direction of the force and the size of the force. The length of the arrow represents the size of the force, and where it's pointing shows the direction that the force is pushing or pulling. Once we know that, we can then move on to working out the resultant force. So this car has 4 forces acting on it. We've got the forwards thrust from the engine, we've got air resistance acting against the motion, we've got weight pulling it down, and the normal reaction force from the ground keeping it from sinking into the ground. So what's the point of the resultant force? Well, the resultant force is a single force that has the same effect as all those other forces. So in this case, we want one force that combines all the 4 forces working on the car, and that will allow us to do some calculations more easily. It will allow us to tell what is happening to the motion of that car as a result of the 4 forces that are acting. So let's start with the forces that are acting exactly in opposite directions. So in this case, we've got 2 vertical forces and they both have the same size. So these guys are going to cancel each other out. So the total resultant force here vertically is 0 newtons. Now, if we look horizontally, we've got these 2 forces. They are not the same size. So what we do when that occurs is we take the larger force, which is 1000 newtons here, and subtract the smaller force. So we are going to get the size of a resultant force here of 250 newtons, and then the direction of the resultant force is the direction of the larger force. So it's going to be to the right or forwards. So there we go. We've now condensed all those forces acting on the car into one 250 newton force, and it is acting forwards on the car. And this will allow us then to calculate the acceleration of the car if we know its mass. But what happens if you haven't got forces that are exactly opposite each other? What if they're at a funny angle? Well, this is where scale diagrams come in. So here we've got a different problem. Instead of the forces being nicely opposite each other, this time we've got 2 forces pulling at a 40-degree angle. So what do we do? Well, there's 2 options. We can either draw a scale diagram or we can use trigonometry. Now I'm going to leave the trigonometry for another video, so I'm just going to show you how to do a scale diagram. We're going to treat the 2 forces that we have as 2 sides of a parallelogram, and that will allow us to work out the resultant force. So firstly, we need to draw the remaining 2 sides of the parallelogram over here. So what we're going to need to do is figure out what angle needs to be here in order to draw the next side of the parallelogram, which is going to go at a slight angle here. Now, something about parallelograms is that adjacent angles, so this angle and the angle down here, must add up to 180 degrees. So what we can do to work out what the angle here must be is we can do 180 degrees minus the angle we know, which is 40 degrees. So the angle there is going to be 140 degrees. So measure that with a protractor. And then what we're going to need to do is we are going to draw the new force, and it has to be exactly the same length as the other side of the parallelogram. So this force here is the side of the parallelogram that this side has to be the same length as. So let's swap this for one I did earlier. There we go, that's much better. So this side is now exactly the same length as the force on the opposite side, and we have 140 degrees in between the bottom side and this new side. Now we're going to do the same up here to complete the parallelogram. Now, to be honest, if you've done this correctly and accurately, you should just be able to get your ruler, line up here and draw the extra side of the parallelogram. But it is worth checking when you do that this angle here is also 140 degrees and the distance here is the same as the length of this force. There we go. Now we've got our parallelogram. How do we work out the resultant force? Well, what we're going to do is we're going to join the vertex of the parallelogram, remember vertex means corner, with the opposite corner of the parallelogram. Here we go, here's one I made earlier. So the green arrow represents the resultant force. To get the size of the force, we now need to work out the scale of the forces that we were given in the first place. So what we're going to do is we're going to divide the size of one of the forces by the length of its arrow to get the number of newtons per centimetre. We're then going to multiply that scale, the number of newtons per centimetre, by the length of the resultant force in centimetres, and that will give us the size of the force. So let me show you how to do that. Now I chose this diagram so that on my screen this was 4 centimetres. Now on an exam you would need to measure this with a ruler to work it out. So then to get our scale we take the force, which in this case was 20 kilonewtons, and then we're going to divide it by how long the arrow was for that force. So in this case 4 centimetres. So that will give us 5 kilonewtons per centimetre. Now the next thing to do is measure the length of the resultant force arrow. So the length of our resultant force arrow is 7.5 centimetres on my screen. To get the force, we multiply the length that we just measured by the scale that we got from the original forces. So it's now going to be 7.5 times our 5 kilonewtons per centimetre, which will give us 37.5 kilonewtons. So the resultant force acting on this plane is 37.5 kilonewtons. If you're asked for the direction, what you'll need to do is get your protractor and you will need to measure it from whichever point you've been asked to give the angle for the direction. So if it was give the direction with respect to the upper 20 kilonewton force, then what you're going to do is you're going to measure the angle here, which in actual fact, the way the question is set up, it would actually be 20 degrees, it'd be half what was given. But depending on the question, it could be anything. Next time I'm going to show you how to solve this problem using trigonometry. So hit the bell, like and subscribe if you want to be notified when the next video comes out. Hope that's helped.